Hello students, in today's class we are going to see the miscellaneous exercise on chapter sequences and series. So as the exercise name says, we are going to see the miscellaneous problems on all the types. So what are all the things we have learnt in this chapter about AP, GP, AM, GM and some special series, right? So what am I going to do in today's class is I am going to give you the gist or the clues to solve 1 to 15 problems and you are going to solve the problems. So listen to my instructions and hints carefully, make a note in your notebook and then start solving your problems. So let us move on to our first question. Show that sum of m plus nth and m minus nth terms of an AP is equal to twice the mth term. So what is given? Sum of m plus nth and m minus nth terms of an AP is equal to twice the mth term, which means a m plus n plus a m minus n equals to 2 times a n. We know what is the formula for a n, right? What is the formula? A plus n minus 1 times d. So in this formula, first you substitute n as m plus n, you will get one equation. M minus n, you will get another equation and add these two and check are you getting 2am or not, which can be easily arrived. Now let us move on to the next question. If the sum of three numbers in AP is 24 and their product is 440, find the numbers. These are all very easy problems. When we talk about three numbers in AP, what are those three numbers? A minus D, A plus D. So what is given in the question? Sum of these three numbers is 24 and their product of these three numbers is 440. So you will get two equations, right? So if you simplify it, you can find out what is your A value. And if you simplify this and if you substitute A value here, you can find what is your D. Once you know A and D, you can substitute here to get your three numbers. Alright? Hope you understood. Your next question. Let the sum of n, 2n, 3n terms of an AP be S1, S2 and S3 respectively. Show that S3 is equals to 3 times S2 minus S1. This is also in the same way. Sn is sum of n terms. What is Sn formula in AP? N by 2 into 2a plus n minus 1 times d. Right? In that we are going to put n and then 2n and then 3n, which Sn denotes S1. S2n denotes S2 and S3n denotes S3, right? So we will get an equation for S1, S2 and S3. Now find what is S2 minus S1 and multiply it 3 times and check whether are you getting S3, right? See, Sn is n by 2 into 2a plus n minus 1 times d. Sn is S1 and S2n is S2, S3n is S3. We will get three equations by substituting n as 2n and 3n. Find S2 minus S1, multiply it by 3 and check whether are you getting S3 here. Right? Hope you can do this. Next sum. Find the sum of all numbers between 200 and 400 which are divisible by 7. These type of problem we have done in exercise itself. Sum of all numbers between 200 and 400. So what is the, so you have to list out the multiples of 7 in between 200 and 400. So what is the first multiple of 7 after 200? Which is 203, right? So the next number is going to be plus 7. So 210. The next number is 217. Likewise it goes on and your last number 400 is not divisible by 7. So you have to find the number which is divisible by 7 less than 400. You know how to find it. So which is 399. So clearly this is a AP, right? With a common difference is 7 and first term has 203 and your last term is 399. They asked you to find your n. First they asked you to find the sum of all these numbers. So in order to find Sn, we need to know what is our n first, right? So you can very well find what is your n. How? Using your last term. using your last term an formula, we can find what is our n. Once you know n, you can substitute in Sn formula and get the answer. Yes, hope you can do this. Your next question, find the sum of integers from 1 to 100 that are divisible by 2 or 5. 2 or 5. Where we came across this r? In our sets, hope you remember. When it comes to union, we will use r. When it comes to intersection, we will use and. So when it is divisible by 2 or 5, what does it mean? It can be divisible by 5 or it can be divisible by 2. So how will you find your union? A union B is n of A plus n of B minus n of A intersection B. The same thing only we are going to use it here. So what are we going to do now? We are going to find the sum of integers which are divisible by 2 plus sum of integers divisible by 5, and we are going to subtract the now sum of integers which is divisible by both 2 and 5. So what are the integers divisible by 2 between 1 and 100? 2, 4, 6 till 100. What are the numbers divisible by 5? Between 1 and 100, from 1 to 100 actually, it is not between, from 1 to 100. So you can include your 100 as well. 5, 10, 15 etc. till 100. Which are the numbers which is divisible by both 2 and 5? 10, 20 etc. till 100. So you need to find Sn of this, Sn of this and then Sn of this, and then you have to add these two and subtract this. Okay, and this is clearly an AP, right? With the first term 2 and your common difference is 2 again, and your last term is 100. This is also an AP with first term 5, common difference 5, and your last term is 100. With that you can find what is your n. The same way this is also in AP with a common difference 10, first term 10 and your last term is 100. So you can find what is your n here. So apply Sn formula, find these values, add these two and subtract the third one, right? Now let us move on to our sixth question. Find the sum of all 2-digit numbers which when divided by 4 yields 1 as remainder. So what are the 2-digit number which yields 1 as remainder when divided by 4? Which is the first 2-digit number which is divisible by 4? 12. 4 3s are 12. 12 is the first 2-digit number divisible by 4. So what will be the first 2-digit number which is when divided by 4 yield 1 as remainder? 12 plus 1, which is 13, right? So after 13 it will be 17 because 4 4s are 16. 16 is exactly divisible. So if you add 1 only, it will leave a remainder 1. So your sequence will be like this: 13, 17, 21, etc. And your 96 is the last 2-digit number which is divisible by 4. Therefore, you have to add 1 to it. So it will become 97. And clearly again this is a AP with first term 13, common difference 4, last term 97. You can very well find your Sn. That will give you the answer, right? Next question, if f is a function satisfying f of x plus y equal to f of x into f of y for all xy belongs to n such that f of 1 is 3 and summation x is equal to 1 to n fx is 120, find the value of n. Now how can you solve this? This is also a easy problem. See, here it is given f of 1 is 3. Now they have given f of 1 plus f of 2 plus f of 3 plus etc. f of n is 120. So for that we need to know what is our f of 2, f of 3, f of 4, right? So first let us find what is our f of 2. f of 2 can be written as f of 1 plus 1. Why we need to express like this? Because the definition is given in terms of sum of two numbers only. So f of 2 can be written as f of 1 plus 1, which is going to be f of 1 into f of 1, which is 3 into 3, which is 9. Then f of 3 can be written as f of 1 plus 2, right? So which is f of 1 into f of 2, which is 3 into f of 2, we found it as 9, which is 27. Likewise we can find. So if you check out the sequence is 3, 9, 27, likewise it goes on. And hence it is clearly a GP with first term A and your common ratio is 3 here, right? Because by multiplying 3 only we are getting the next number, and it is given Sn is 120. How Sn is 120? Because it is given summation of f of 1, f of 2 etc. is 120, which means if we add all these numbers we are getting 120, which is nothing but sum, right? So sum to n terms is 120. What they asked you to find? They asked you to find n. So if we substitute in Sn formula the value of a, r, we can very well find what is our n. That's it, right? Hope you understood. Let us move on to our next question now. Let us see our 8th question. The sum of some terms of GP is 315, whose first term and common ratio are 5 and 2 respectively. Find the last term and the number of terms. So it is given sum of some terms. They didn't give how many terms. So Sn is 315. First term a is 5, r is 2. Find the last term and number of terms. This can be easily done. Yes, using Sn formula, find what is your n and then find your an term, that is going to give your last term, right? Next question. The first term of a GP is 1. A is 1. Sum of the third term and the fifth term is 90, which means A3 plus A5 is 90. They asked you to find the common ratio. So, which means A3 plus A5. A3 is going to be AR squared plus A5 is going to be AR power 4, because AR power n minus 1 is your formula, which is 90, and these two things are given. In this, if we substitute A value, you can find out what is your R. That's what they asked you to find. Common ratio only they asked you to find. Yes. Let us move on to our next question, 10th one. The sum of three numbers in GP is 56. If we subtract 1, 7, 21 from these numbers in that order, we obtain an arithmetic progression. Find the numbers. It's quite interesting. The three numbers are in GP. If we subtract the numbers 1, 7, 21 from those three numbers in the same order, they will form an AP. So, first, what are the three numbers? AR square are the three numbers in GP, right? It is given the sum of three numbers is 56. So, if we subtract 1 from the first number, 7 from the second number, 21 from the third number, it forms a AP. That's what given. They asked you to find the three numbers. If it forms a AP, what we know that they have a common difference. They have a common difference, which means second term minus first term should be equal to third term minus second term, right? So that's what I have written here. So if you resolve it, you will get an equation in A and R. Again, from this A plus AR squared, if you resolve it, you will get another equation in A and R. And we know if we divide these two equations, you can find the value of R. We will get two values of R. Accordingly, you can find out two values of A. Right? So, this is also mere calculation only. Hope you can do this. Let us move on to our 11th question. Yes, 11th question. A GP consists of an even number of terms. If the sum of all the terms is 5 times the sum of terms occupying odd places, then find its common ratio. This is again another interesting question. See, it consists of even number of terms. So, A1, A2, etc., A2n, and clearly it is given it's a GP. And it is given the sum of all the terms is equal to 5 times sum of the terms in the odd places. So, which are all the terms in the odd places? A1, A3, etc., A2n minus 1, because A2n is the even place. The term before A2n is going to be A2n minus 1. That is going to be the odd place. So, this is what given in the question. They asked you to find the common ratio. So, how can we find this? This is very easy again, right? See, we got an equation like this. Here also A1, here also A1. So, we have here all the terms are there. Here we have only odd terms. So, we can bring the odd terms to this side and we will remain with only the even terms here. A2, A4, etc., A2n. So, odd terms, if you bring it to the other side, what will happen? Already 5a1 is there. I am going to subtract 1an, so it will become 4a1. Already 5a3, I am going to subtract 1a3, so it will become 4a3. Likewise, everything will reduce 1. So 4 into, it has become a1 plus a3 plus etc. till a2n minus 1. Right? Now if you see, these are all terms of GP, and now one term is missing out, and hence again it is going to be in GP only. We have learnt it, right? So this is a GP with your first term as your second term. Here this is a GP with the first term as your first term only. So what is SN formula? A into r power n minus 1 divided by r minus 1. Now your A is going to be your second term. What is your second term? AR. AR into, how many terms are here? 2, 4, etc. 2n, totally n terms only. 2 to 2n, how many terms are there? Only even terms. So n terms. So r power n minus 1 divided by r minus 1. Similarly here only odd numbers, 1 to 2n minus 1. So how many terms are there? Again n terms only. But here the first term is a1. a1 is a, right? So after substituting the values, if you cancel, everything is getting cancelled. So you left with r equal to 4. Directly the answer. Yes? Hope you understood this question. Let us move on to the next question now. So we are in 12th question now. The sum of the first 4 terms of an AP is 56. The sum of the last 4 terms is 112. If its first term is 11, find the number of terms. So what is given? Sum of first 4 terms. It is AP given in the question. So 4 terms is going to be A plus D, A plus 2D, A plus 3D, which is going to be 56. The last 4 terms. How will you get your last 4 terms? Your last term is going to be nth term. Nth term is A plus n minus 1 times D, right? So the term before that is going to be A plus n minus 2 times D. The term before A plus n minus 3 times D. The term before A plus n minus 4 times D, right? If you add the last 4 terms, it is 112. And the first term is 11, which is also given in the question. They asked you to find n. So it's very easy. You got 2 equations here in A and D. And you know the value of A. If you substitute the value of A in your first equation, you can very well find what is your D. Once you know your D, you substitute in this, you can get your n, right? It's very easy problem. Let us move on to our next question. We are in 13th one. They have given you some relation A plus Bx divided by A minus Bx, B plus Cx divided by B minus Cx, C plus Dx divided by C minus Dx. Show that A, B, C, D are in GP. How you will show the 4 numbers are in GP? They should have a common ratio, which means we need to show that B by A equal to C by B equal to D by C. That's what we need to prove. We got some relation. So first take these two, cross multiply it and solve it, simplify it. You will get a relation in ABC. ABC. Again you take these two, solve it and again simplify it. You will get a relation in BC and D. And try to compare those two answers. Obviously you will end up with this only. Yes? Yes. Let us move on to the next one, 14th. Let S be the sum, P the product and R the sum of reciprocals of n terms in a GP. Prove that P squared R power n equal to Sm. So what is given? S is the sum of the terms of the GP. So A plus AR square, etc. What is P? Product of the terms. What is R? Sum of their reciprocals. So 1 by A plus 1 by AR plus 1 by AR square plus etc. Now to prove that P square R power n equal to Sn. Now let us find what is our S. S is sum of n terms. So A into R power n minus 1 divided by R minus 1. What is P? A into C product. How many A's are there? A power n into R power. Base is same, so we can add the powers, right? So it is going to be 1 plus 2 plus etc. up to n minus 1, because your nth term is going to be A R power n minus 1 only. In hurry, don't write n. Nth term n you should not write, because it starts from A, so your nth term will be A R power n minus 1. So it is going to be n minus 1. The power is sum of n terms. So what is the sum of n terms formula? N into n plus 1 by 2. Now we have till n minus 1 only. So n minus 1 into n minus 1 plus 1. So plus 1 minus 1 will get cancelled. So we will get n into n minus 1 by 2. Right. Similarly, let us simplify for a. I have taken 1 by a as common. So you will get 1 plus 1 by r plus 1 by r square etc. 1 by r power n minus 1. In the same argument as we had earlier, the last term will have power n minus 1 only, not n. So if we take LCM, r power n minus 1 is our LCM. So we need to multiply here r minus 1. Here we have 1 r. So power n minus 2 we need to multiply. Here we have r squared. So n minus 3 we need to multiply. Likewise it goes on till last term is r power n minus 1. So it is 1. Right. Again, if you see the numerator, it is clearly a GP. Starts from 1 with common ratio r. So sum to n terms, what is the formula? A into r power n minus 1 divided by r minus 1. And if you see, it has n terms. Since it starts from 1 till r power n minus 1, it has n terms. So r power n minus 1, first term is 1 divided by r minus 1. Already we have r power n minus 1, I have written here. Right. Now, so we found what is our r. Now we need to prove p square r power n equal to s power n. So let us find what is sp squared r power n. We will consider p squared r power n. So p we have found out already, the whole square, into r value the whole power n. Now simplify it, 2n, a power 2n, 2 will get cancelled, n into n minus 1. Here 1 by a power n, r power n minus 1 into n. Then numerator the whole power n we will get r minus 1 the whole power n. If you see, these two terms will get cancelled. Which two terms will get cancelled? R power n into n minus 1, r power n into n minus 1 will get cancelled. So we got, and a power n, a power 2n, so n will be remaining. So a power n into r power n minus 1 the whole power n, denominator r minus n the whole power n. So whole power n we can write, which is nothing but s power n, because s is a into r power n minus 1 divided by r minus 1. So it is whole power n. Hence we proved p squared r power n is equal to s power n. Yes, hope you understood this problem. Let us move on to our last question. Last question is, the pth, qth and rth terms of an AP are a, b, c respectively. Show that q minus r into a plus r minus p into b plus p minus q into c equal to 0. This kind of problem also we have done in our exercise. So that reference you can solve it. It is given, I have taken the first term as capital A to avoid confusion with these terms. We know what is an. So we will get 3 equations. If you simplify it further, if you substitute in this equation, you can very well prove this. Right. So with this, let us wind up today's class. I have given all the clues to solve question number 1 till 15. So today's homework is going to be miscellaneous exercise question number 1 to 15. Miscellaneous exercise question number 1 to 15 you have to solve and post it in the group. Even then, if you have any doubts, you can ask me. Thank you, students.